To spice up your version 1 even more and create an enclosure that uses a fixing method that you can use in pretty much any design you ever want, we are going to talk about threaded inserts. Now, I have a set of threaded inserts here. They're this brass part here. Basically, they can take certain size screws and you can fix different parts together using this technique. Now, what I wanted to show you, this is just Matter Hacker's website, was this animated GIF here. This is a threaded insert being inserted into a part using a soldering iron. And once you have this insert in here, you'll see it has little threads in there that accept a screw. You can actually go ahead and screw a screw into that threaded insert, and it gives you a nice rigid anchor to have two parts stuck together. Now, what we're going to do, I've gone ahead and I've duplicated our enclosure 1, so I'm assuming you've watched my other video to make your first basic case. And what we're going to do is we are going to hop into our enclosure guide. It's our first thing that we need to edit. Now, we need to make a bunch of room in this example for our threaded inserts, and what I'm going to do is I'm going to make this outer offset 9 millimeters instead of 2. Now, what happens is it makes the walls around the whole thing extrude. We don't like that, so I'm going to go ahead and change this dimension right here to 2, and once I do that, Onshape is going to yell at me. So it didn't actually take that 2 change right there. So let's see, can I go through? Why do you not like me, Onshape, right now? I'm going to try to make that again. Looks like my computer's a little sleepy. So we're going to make that dimension and change it to 2. Now again, it's going to yell at me. If we mouse over here at our different offset constraints, I can find the one that lights up those 2 horizontal lines where I made those dimensions between. I can click it and I can click delete, and then we have that dimension that we want. Again, we want 2 here because we want to be able to plug our USB into the computer and have it work, but we still want to have some good wall thickness here for our threaded inserts. Now, once I've checked this, I can hit the check, and we just want to double check again that our enclosure cap is still there. It looks great. I actually want to change that cap to be a different thickness, so we can go ahead here and change our extrude 1, the depth of that, instead of being 1 millimeter, let's just give it a little extra thickness and we'll make it 2. We may need to edit this again in the future, but top cap, and we're good to go. I'm going to turn off the enclosure cap, and we're going to work within here to start. Now, in order to get going on this, we are going to change some surface on here so that we have some holes in it. So if you were watching my press fit video a moment ago, we're going to be essentially doing the same thing. We are going to create a sketch on this surface up here, and once we have a sketch on this surface, we are going to create a point. That point's going to be out in space up here, and we want to actually give it some dimension. So we're going to dimension between the top line and the point, and then we're going to dimension between the side line and the point. We're going to get 2 dimensions. These 2 dimensions are going to guide the center point of our hole. And then, again, this hole is where our our threaded insert is going to reside. Now, if I go ahead and take a look from here, we probably want to make it so that our hole is roughly 4 millimeters from the side, and like 5 millimeters sounds good from the top. Once we do that, we can create a circle, and that circle can hang out right here. This circle is going to be the rough diameter of our threaded insert that we're placing in there. And generally they're like 4.5 millimeters, 4.9 millimeters, not 49, 4.9. Has been like a pretty solid sizing for me, especially since we're melting something into the plastic. It being a little bit bigger is okay, because that plastic will deform as it melts in there. Once we have this, we can create some construction lines, so LQ, and we can find the midpoints of everything here, and we're going to make one line from the top to bottom midpoint, and one line from the side to side midpoint. And we can actually use mirror to mirror our circle around. Now I'm mirroring it left to right. Now I'm going to mirror these two top to bottom, and we can hit the good old check. Now once we have this, we can go ahead and hit extrude, and I'm just going to do an extrude remove for this round, and we're going to try extruding to a depth of I think 6 millimeters is actually too deep. I think that's like all the way through. Let's see. Yeah, let's go ahead and do 5. And what we may actually need to do, let's hit 6. And then we're going to go to the bottom of the bottom enclosure. So if you remember way back when, in the good old days, we're going to change this dimension from 1 to 2. Give ourselves a little bit more thickness. Now we're not seeing through the part, we just have a hole. So we've created a cavity for 4 threaded inserts to be melted into. We've created this, essentially, in the bottom case, in the side walls of our case. Now what we need to do is edit our cap. Now, in order to edit our cap properly, we actually need to make a new sketch. In order to save us some time, though, I'm going to hop back into this case right here. I'm going to this sketch. I'm going to call this threaded insert, and I'm going to rename this threaded insert. And what I'm going to do very briefly is I am going to mirror these holes, or these pins, all the way around. So there's one mirror, and then another. And I may actually not need these, but we do need some reference points in a little bit. Doesn't look like it's happy about that. We'll roll with it. I'm gonna turn on the cap. I'm gonna make a new sketch on the top of the cap. And what we need to do is actually use project some lines up there. So let's turn this back on, and let's use project to get these points up on top of our cap. Once we have these points, we can close this. We can call it hole reference. We can now use our hole tool to create some chamfered holes in the top of our cap here. And the way we're going to do this, we're going to select each one of these points using the hole tool. So this is our hole tool up here. And what we're actually going to do is we are going to select, instead of simple, we're going to do countersunk. And instead of doing just a custom sizing, we're actually going to tell it that we want it to be a standard ISO screw size. M5 is a little bit too big for us right now. We're going to change it to M3. And what's going to happen is we're going to have a nicely chamfered screw hole so that when we go to screw our case top into the body with the threaded inserts in it, our screws sit almost nice and flush to our design as possible, to the printed part right here. What I'm going to do, I'm going to just insert a picture of an example that I've created for you, and you'll see what it looks like when we screw something in using the hole feature, and in particular countersunk. If we didn't countersink things, then the screw would rest above and it might get caught on something like in your pocket. It might be annoying. It definitely won't be nice and clean and flush. So that is how to create a threaded insert version of your basic case. The next thing I'm going to show you to really spice things up is how to make a magnetic case. Really good in the future for designing things that need to either snap together with magnets, include embedded magnets, or if you want to make your own sort of product design, you can do that as well. I'll catch you later.